Hi, welcome back to Air Engine Research. Today I'm going to work on a video that explains what I've been doing with my valves over the last few weeks since I made my last video. If you've watched it, you'll recall that I was not satisfied with the way the valves were working. So I've come up with a new way of operating the valve, and also it's a single shaft push-pull valve, so it's much less complicated and a lot better working. It is pretty complicated as far as timing goes, I found out. Um, I've made a couple of versions of the push-pull assembly on the valve and the orbital crankshaft that you'll see as you watch the videos. It's going to be a series of pictures and several videos that I've taken at each step of the way. Some of the connectors I didn't like, and I finally ended up with a flexible connector for each one of the push shafts, which for right now it works pretty good. So I'm going to go ahead and continue with trying to see how much torque the engine will have when I run it under different circumstances. So we'll just go ahead and start showing you those videos. But also I'd like to say, if you are interested in what I'm doing, would you please subscribe, and that way you'll be notified whenever I come up with a new video or a new idea that I want to put a video out on. So why don't we go ahead and let the other part of the video start. I'll go and get that going. Today I'm out in the garage working on the cylinder that I told you about in my last video. This is a single push cylinder with one. I got rid of all that stuff that was on both sides here and all these big flipper things that really have no value. Made it a lot heavier. This is much lighter. I'm making the valve out of aluminum, and well, so far it seems to be working. The only thing that happened, for some reason, now it runs the opposite direction, which is okay. It doesn't really matter. You can just turn the motor around if you want it to run something in a different direction, or turn it back around the other way, and then it'll run the counterclockwise like the other motors or engines that I made and worked with on my little riding a lawnmower conversion. Anyway, it's a little bit sloppy because it's only got one cylinder on it, but it does run even with one cylinder. So I'll show you that in a minute here. And but it won't start by itself unless it's in the right position. It's not as noisy as the other one was, with all those extra flippers and things on it to make the double valve work. So I'm happy with it the way it is. And once it gets to running, and once I get 3 cylinders hooked up, it won't be as noisy either, because then these won't be just, you know, freewheeling or slopping. So that's where I'm at with it for now, and I'm going to keep working. I have to make 2 more of them. This valve, like I said, it's a single shaft, and what I had been having problems with for many months, figuring out how to seal this shaft on the inside. Well, I finally did figure out how. I made all the parts on the outside, all the holes, everything, and then I cut it in half after I drilled all the holes and tapped them so that it goes back perfectly together. And then on the inside, I was able to create a O-ring seat around the shaft and then bolt it back together. So once it's put together, it's just as it should be. And it is a replaceable seat at the top and in the center. Just have to take the 4 mounting bolts out of the bottom and put a new O-ring in it, and you're back in business. So for today, I'm going to go ahead and quit and do like I did the last couple of videos. Go in for a while and have a cup of coffee. So till next time, so long. Hi, and welcome back to my workshop. I've been working some more on the valving systems, and I've made some changes that I don't know whether will be a good permanent fix or not. But I ended up getting rid of the little swivel things that I had made for putting on the ends of the valves up here at the top, which was working fairly well, but they were still trying to bind up whenever it got in this position where the things were really twisting and moving as these lower cylinders make their oscillation moves back and forth. So what I've tried to do is use these connectors instead, which are flexible, and I think that will allow me to do what I want to do. I still don't have 1 cylinder on here. I need some more of the bolts that attach this cylinder to this, or the valve to the cylinder. So when I get those Monday, then I'll add that valve back to it. But I don't have it completely put together yet either. So I have the parts cut and made, but I don't have it put together yet. I've got to make the gaskets that go in between, and then also I'll have to make the gasket that goes on the back side that actually attaches the cylinder to it, or the valve to it in this case. So I'll get that done later on Monday and do some more work on it then. But for now, it is running and it does okay. It's a little bit noisy because of this cylinder slapping yet, but once it gets pressure put to it, then that'll stop that slapping noise. And it shouldn't be just too noisy then either. I've still got to make a balance wheel for on the back side to eliminate a lot of that vibration, which I think will happen once I get a balance wheel put on it. So for now, I'm going to have to wait and go in Monday and see about getting some more of the bolts that I need. So for now, I guess I'll just quit and go in the house and have a cup of coffee. So until I get a little bit more done, I'll wait and add that to this series of videos that'll show you later on my main video that I put on YouTube. So till later, so long. Back in the garage again, and now I have all three of the valves mounted and in operational order. So now I'll have to see about making some more of the things permanent, since I've got everything laid out and know where it has to be and what position, and see what goes from there. But it runs a lot smoother now with 3 cylinders. And I think you agree that it's much quieter too. Got a little miss in it, sounds like. It's this one here that's causing it, so have to maybe adjust that and try it again. Everything's pretty easy to adjust. You just loosen a nut here or there and either turn it in or out. I think it has to go out, but not sure. Just a test run. Well, I'm back in the workshop again, and today I've been working with the timing. Since I've got it, the valves and things on, trying to figure out the best way to have a procedure to time it. And I've measured like the length of the shaft on the outside, and this one is different than this one and these two. This one, the shaft goes up and down 17.5 millimeters. This one, the shaft goes back and forth 22 millimeters. And this one, the shaft goes back and forth 22 millimeters. The tip that is on the end of each one of the push rods is what determines the timing, actually. And the tips are different again also. Is 18 millimeters and 22 millimeters, 22 millimeters in length. And what I found out is if you look at the exhaust hole on each one of them with a light, you can rotate the rotating crank till it goes in and out to each position. And then as you look, you can see when the tip of the push rod, where the exhaust part actually begins, you can tell when it's going to be timed right to let the exhaust out, and that works okay then. And right now I've got it pretty well timed, I think. One way you can tell when it's out of time is it won't start in every position. If one of the push rods is a little bit off, it doesn't open the air inlet at the correct time, then it won't start running. This one, this part of the crank on this cylinder, when it is right there, it has to be just at the point where it pushes the ball off of the seat to let air into it to push the cylinder down. And if it's not, well, if it'll just stop, because this one pushes this part here over to that side and then it stops. This one has to push it to continue the rotation. When it gets up to this point, it's up here. Now this one has to be at just the point where it starts to push the ball so it can continue on around. And then each one in series does that as it goes. So if I've got it timed right, it should start. Well, it does do it. There's a lot of noise because I've got it mounted to my workbench, which is hollow. So any noise that you hear is going to be multiplied just like a loudspeaker. But I guess the next thing I'll do is try to see what kind of torque it has. But again, this is not the final version. This one only has 7/8, or not, I'm sorry, it's got 3/4 inch pistons in it. So later on I'll have it up into like 1 1/8 or 1 1/4 on the piston size, if the smaller pistons aren't producing enough torque to be able to use it in a vehicle that I'm wanting to put it in. I have a Ram 50 pickup truck, 4-cylinder, 5-speed, and my intention is to eventually take the engine out and replace it with this design engine. Although it won't be on a wooden base, it'll have aluminum framework, and also eventually I'm going to replace the cylinders with aluminum cylinders. And as far as wear goes with aluminum cylinders, it doesn't matter because there's no rings in it. The only seal in it is leather washers, so they don't wear the cylinder like piston rings would. And it only gets lubricated from a little bit of oil that you put in initially whenever you put the leather seals in. And it can also be later, if I want to, I could put grease seals or grease fittings in it, and you could grease it then also, which would make it more efficient also. So I guess for now I'll just run it for a few minutes, and then I'm going to go in and have a cup of coffee. be quite as vibrating either once I get the aluminum framework and actually bolt it to a metal frame of some vehicle. So I guess I'll just go ahead and say so long for this video. Well, if you're interested in what I'm doing, I'd appreciate it if you'd subscribe. You'll be notified then anytime I have a new update, or if I'm working on it, or anything else that I might put out as far as the video goes. So if you're interested, please subscribe, and I'll thank you for that.